Welcome to Hyperfiltration's Factory Side Chat podcast. My name is Scott Howard, the Strategic Accounts Program Manager at Donaldson Hypro. Joining me today is Mike Flick. Mike, if you could introduce yourself.
Thanks, Scott. I'm Mike Flick. I'm the Business Development Manager for Hypro in the Northern North America region, and I have 20 plus years as a fluid power engineer. And today we're going to talk about the BT breather with T.R.A.P technology.
Yes, thank you, Mike. In this episode, as Mike mentioned, we're going to talk about breather technology. We will also be discussing the reasons to select the BT breather over traditional desiccant breather technology. So to start off with, Mike, if you could explain, what does BT breather with T.R.A.P technology mean?
So the BT breather is like a standard breather. However, the T.R.A.P technology is really what makes it special. The T.R.A.P technology stands for Thermally Reactive Advanced Protection, and we'll get into the hows and whys a little bit more into the presentation.
Okay, thank you, Mike. To start off with, let's do a little bit of education, the difference in adsorption versus absorption, and which one of these the BT breather with T.R.A.P technology utilizes.
So the T.R.A.P technology is unique versus your traditional water removal products. Um, it competes very well against desiccant breathers. And the reason why is your desiccant breather practices absorption, where your T.R.A.P breather uses adsorption. And the difference between the two is, if you could picture a sponge, absorption absorbs the water into the sponge, and you can wring the water out and then reuse the sponge to collect more water. Adsorption, the sponge is not collecting the water. Absorption, the water is just on the surface of the sponge, and that is why it feels damp after you wring it out. So with adsorption, the water is just on the surface and it is not in the molecules of the sponge. So it can easily take in water and give up water at the same time.
So using that terminology, as we have air that enters a reservoir and then is expelled from the reservoir, what exactly happens within the BT breather?
And that's why the adsorption process is so important. So as your hydraulic reservoir takes in warm, moist air as it's breathing in, the T.R.A.P breather acts as a barrier. And that chemical in the filter, that barrier, lets the water stay on the edge through an adsorption process and allows clean, dry air to flow into the reservoir. Then when the reservoir has to expel air, like a cylinder is retracting and you need to bring that oil back into the tank, what happens is that moist, warm air then pushes back out of the reservoir, and any moisture that's collected in the T.R.A.P breather is then expelled out of the breather, and then it's nice and dry and it's ready to take in new, moist, wet air the next time it breathes in. And that's why it's regenerative. And because it's regenerative, the water absorbing of the BT T.R.A.P breather is as good on day one as it is on day 300 or however long the breather lasts. The reason why you change these breathers out isn't because they can no longer take moisture out of the air. It's actually the filter in there becomes dirty.
So using that the terminology that we like to refer to as the saturation phase and then the regeneration phase, and talking about percent relative humidity, can you explain what happens as the wet air or normal air, which does have humidity, goes through the BT breather, what we call the saturation phase? Kind of talk about the percent relative humidity and then where it would drop through to, and during the regeneration phase, and prepare itself for the next incoming airflow.
So if you took the BT breather with T.R.A.P technology and put it in a lab and continuously drew air in through the breather, at some point, it's going to reach saturation where it can no longer uh, take or remove any water, just like a desiccant. However, where we totally differ is that desiccant will not regenerate. When that desiccant is full of moisture, it is time to remove it and replace it with a new one. However, with the BT trap breather, as we can reverse that airflow, and instead of breathing in, now we're breathing out, and that will get any moisture out of the trap breather. And as long as the filter is clean, that trap breather is ready to remove water again. And it, like I said previously, that is not the part of the breather that wears out. You can totally regenerate that and keep on using it to remove water over and over again as long as the filter is clean. And the nice thing about this, the trap breather, it will maintain a 50% or below relative humidity in your oil.
One of the questions that we get asked is, okay, well, you say it will completely or it will continue to regenerate itself. Can you give an example? We've done some testing of this technology to find out, okay, how long can we continue to regenerate before it loses its capability? Do you have an example that you'd like to share?
Sure, I can. We can do a couple examples. The first one I'm going to share with you is in our lab, we did over 3,000 cycles of inhales and exhales through the breather. And we also compared that against the desiccant. And I can tell you, after 3,000 cycles, all the desiccants were filled up. Some of them didn't even last to 1,500 cycles. And the trap breather at 3,000 cycles was estimated that it could go up to closer to 10,000 cycles before it needed to be replaced. Now, that's in the lab. In real life, we have several tests where we went in the field, trap breather against desiccant breathers, and we put them in situations where they had to last 12 to 14 months out in the field. And not only did they last 12 to 14 months, but they kept the fluid drier. And in some cases, they even solved another problem that a desiccant breather cannot even touch. They do have an oil mist removal capability in the trap breather, and that is one other thing that puts it above the desiccant breather.
So, Mike, in a field test that we perform a head-to-head BT breather versus the desiccant, in this application, this would be on a gearbox where there's really not much air movement except for whenever you heat up the gearbox and then you cool it down. We would consider to be the easiest application for a desiccant breather. How did we stack up with the BT breather versus the desiccant in this application?
Gearboxes are a great application, Scott, for the BT breather. Um, as long as we have one air exchange in a 24-hour period, that is enough to make the BT breather work. And that having that air exchange once in 24 hours is all you need to keep up on your water removal. And how that occurs is when you have that air exchange, it doesn't, and think of hot to cold, nighttime and daytime. So if it's 100 degrees outside or 120 degrees around your machine during the day, and then that cools off in the evening, say 20 or 30 degrees, that difference in temperature is what's going to get you that air exchange for the trap breather to make it work. Now, because we have that air exchange and we're exchanging dry air in and out, and we're using the trap breather, it's at 100% peak performance. It winds up lasting a lot longer than your desiccant breather brothers out there. It also keeps because you're not decaying over time with the trap breather, that decay on a desiccant, you may be at 100% usefulness on day one, but on day 50, you may only have 50% usefulness on the desiccant breather left, where the trap breather is as good on day one as it is on day 50, as it is on the day you're going to remove it. So because of that, gearboxes are a great application. We're able to outlast and outperform desiccant breathers, and also they're less expensive than desiccant breathers. So it's a great, great product out in the field. In my 27 years as working in fluid power, I've always found that desiccant breathers are something that maintenance people really don't like because they can physically see the color change and they know that they're just chasing their tails trying to keep water out of their oil. With the T.R.A.P breather, you can put that on there. We can use a differential pressure gauge to track that to see when the filter's full and change it on when it's needed. Or we can do a 6-month PM where you're changing the T.R.A.P breather every 6 months to a year. It's a great product, and not only that, hands above the desiccants.
You mentioned one thing that I'd like to focus on. We know that desiccant breathers can be easily fouled by oil mist. And of course, you can put something in place like a labyrinth flow path between the desiccant breather and the reservoir to try and eliminate that. We don't have to do that with the BT breather. Can you talk about that technology and what we do, why that we have no issues with oil mist fouling?
So Scott is correct. In addition, most people handle that with a tortuous path, which we do have a little bit of a tortuous path on the T.R.A.P breather, but we also have a coalescing disc inside the breather that removes that oil mist. And because we have that coalescing disc, we're able to keep the oil there, and then it does not foul the filter, and it allows the T.R.A.P breather to operate as a T.R.A.P breather. I'm sorry, allows the T.R.A.P breather to operate and remove water and act as a filter without having pesky oil to gum up the works inside it.
You mentioned earlier, or if you didn't, we definitely have spoken about critical applications before. Right now, we're talking about a gearbox, which is a critical application. But let's shift gears and talk about an application where you have an active air exchange in a reservoir. Can you talk about how the BT breather would perform in this application?
So yes, moving on from gearboxes, we can also talk about hydraulic systems. And hydraulic systems have a great air exchange, especially if the system is using cylinders. As you know, cylinders will change the oil level in the tank as they stroke in and out throughout their cycle and throughout the day. So you're getting a greater air exchange in a shorter time than the 24-hour cycle. So, bar none, hydraulic systems are perfect for the T.R.A.P breather. You can even use them on lubrication systems. Lube systems, they're going to have constant flow with a little bit of oil change in the reservoir. But again, you're going to have a similar situation like a gearbox where you're going to have that air exchange between the morning and the night. And that nice air exchange is how you're going to get your air movement through the breather to keep that tank dry and keep stalactites and whatnot from forming on the inside of the reservoir. The only place where the T.R.A.P breather is not recommended, where maybe a desiccant would be a better choice, but in this case, I would actually prefer to go to a true headspace dryer, is storage tanks. Storage tanks, there's not any air exchange, there's not any oil exchange except when you're filling it or taking oil out. So in that case, a static product may not be the best way to go, and you may want to upgrade to an active headspace dryer to keep the top of that storage tank with cool, dry air.
So in that aspect, the headspace dryer would be able to maintain a dry situation in a storage tank for either oils or grains, for example, which would not be a consumable product. And desiccant, even though it would work a little better than the BT breather, it's still a consumable product. So we're not even going to recommend desiccant in that application.
Correct.
Okay, Mike, so just to review on the storage tanks, we're still not recommending a desiccant breather because that's a consumable product where we would recommend a headspace dryer. So for liquids like oils, we're going to keep the headspace dry so the oil stays dry. for grains and items like that in a storage tank. We maintain a dry headspace so the grain stays dry as well. So that application, we wouldn't recommend the desiccant. Moving back to a non-active air exchange reservoir like a gearbox, which would be the easiest application for a desiccant. We've shown in the lab and the field how the BT breather exceeds the performance of a desiccant there. But then we talk about an active air exchange reservoir like a hydraulic system where the desiccant breather doesn't stand up at all compared to the BT breather with T.R.A.P technology. It has something to do with the temperature difference. If you could review that for us one more time and explain what the advantages are of the BT breather and how the temperature plays a role.
Sure. You think about I'm going to go from the least to the best here. So if you think about a storage tank, the storage tank is static and the temperature is static. So if it's 70 degrees outside, the storage tank is 70 degrees outside. So you don't even have a temperature difference between the oil and outside ambient. Basically, without that temperature difference, everything's static. Now, you move into a gearbox situation or a lubrication system, that could be semi-considered static because whatever oil you're taking out, you're putting right back in. So if you're taking out 5 GPM, the reservoir is getting 5 GPM, so there's not a lot of change there in your oil levels in the tank. However, that oil that you're running in your reservoir is going to be somewhere between 100 and 140 degrees because it's actually performing work, versus the ambient temperature is going to be somewhere between 170 degrees because that's just normal ambient temperature of life in the world. So because of that, you have a natural air exchange. So let's say you're at 120 degrees on the low end for oil and it's 100 degrees outside, you have a 20-degree delta. Now let's say we go down to nighttime and the temperature in the facility goes down to maybe 90 or 85, and now you have an even greater delta for that air exchange to occur. So that's why we're just trying to get one air exchange in a 24-hour cycle for that BT T.R.A.P breather to really work. Hydraulic systems, unless they're hooked to like a hydraulic motor, are the easiest because they are the most turbulent and the most dynamic because of the oil exchange that occurs with cylinders. But really, that temperature dynamic is really why you're getting T.R.A.P breather air exchange, is because of the high temperature of the oil and the lower temperature of the ambient temperature. And of course, as you travel into the evening and nighttime, that ambient temperature gets less and makes that temperature differential even greater. So storage tanks are very much too static. Lube systems and hydraulic systems are the place you want to really focus on your BT T.R.A.P breather upgrades.
It's outstanding information, Mike. Always appreciate your expertise, and this was very good as far as explaining the differences between a BT breather with T.R.A.P technology and a desiccant breather. We're looking out for the customer's best interest and helping reduce their total cost of ownership on an annual basis. And we firmly believe that the upfront price of the BT breather being cheaper than a desiccant to begin with, and also the fact that it lasts longer, will end up saving the customer money while maintaining their water or moisture content in their systems below the limit.
Scott, one last thing if I can add. When we came out with these BT T.R.A.P breathers, I immediately switched from desiccants to T.R.A.P breather, just because I know how maintenance people view them in the field and how they've performed in summertime in humid areas. I switched to the T.R.A.P breather immediately once we came out with this technology, and I haven't looked back.
Yeah, I agree completely. Okay, well, super. Well, thank you all for joining us for our podcast. Please remember to subscribe to this podcast to receive updates when new podcasts are available. Also, follow, like, share, and comment on our various social media channels. Thank you, and I hope you have a nice day.